All right, 14C. What you'll be doing in 14C, so 14A, 14B, you see? You've gone through so far 2 skills. 1, you had to revise, listening, thank you. You had to revise your vertices, edges, okay, degrees. That was all in DP 1.1. Then in part 2, you had to then translate a network graph into a matrix, right? Which is very similar to the communication and dominance part of matrices. And then now on C, what makes this different is you need to know the different types, and there's the notes that I haven't printed out for you, have I? No, I'll print it out now. There is notes that on styles, that is walk, trail, path, circuit, and cycle. So I'm just going to quickly go through it as an understanding of what they are, but the notes that is on style is much more condensed for you. So hopefully those notes will then help you understand. But you need to know these because the key understanding is the second part. This is what they're really wanting to teach you, is to know what a Eulerian trail and circuit is, and then a Hamiltonian path and cycle is. So notice they're using the word path and cycle. You need to know what a circuit, trail, path, and cycle is in order to understand or remember those points. So those are the key points to understand, but the first part of your exercise is to get you to understand the difference between a walk, a trail, a path, a circuit, and a cycle. So I try to picture it as well. For me, cycles and circuits both start with C, so I think of them as totally separate components. Then I start off by saying, all right, well, what's a walk? Okay, so they say a walk, when you draw your network, a walk is a sequence of edges linking successive vertices in a graph. So essentially, any point to any other point is called a walk. Okay, so here's an example of what they've drawn as a walk. Here's a walk. You started off at A, you went to C, then you went back to A, and then you went to D, and then G. Okay? So going from one point to the next, doesn't matter, you don't end up at the same point again. This is called a walk. Right? What makes a walk different to a trail? So let's have a look. What is the difference between a walk and a trail? A trail is specifically no repeated edges. Now you know what an edge is. Edge is one of those lines. So that means you can't cross any pathways. Any pathways, you can't cross a repeated edge again. So here's an example of a trail. Let's have a look at the difference between a trail and a walk. You start off at B, you went down to E, you went down to F, so across to F, up to C, across back to B again. Notice that there's a repetition of vertices. That's okay. You can repeat another vertex, but you're not repeating any edges. You're going through the edges once. So then you end up at A. Okay, so this is called a trail because there are no repeated edges, but it's okay to have repeated vertices. This is the clear difference between a path. So if you go back up again, so notice why I'm splitting it up. A walk, you walk anywhere. From A, you can go back to same vertices, you can repeat a vertex, you can repeat an edge, it's okay, no rules. A trail, on the other hand, has a rule. It says no repeated edges. So you can't go across the same path, but you can cross the same vertex. A path, on the other hand, is no repeated edges and no repeated vertices. Okay, so you can't repeat the same corners and you can't repeat the same pathway that you would have gone. That's called a path. Okay, so have a look. Let's have a look at a pathway. So a path, you start off at A, so that's one edge, that's one vertex. D to C, I'm never repeating D and C again. And then C to F, I've never taken that path and I've never crossed that vertex. And then again, I go to F to E, E to B. This is called a path. Okay, so notice I've gone through each vertex once, I've gone through each edge once, and I've walked from A to B. I didn't come back to the same point. This is called a path. So it's different to a trail, because a trail can repeat the vertices, but they can't repeat edges. A walk, you can go anywhere you want. So once you understand that, that's the difference now separating walk, path, and trail from circuit and cycle. So I like to think of this separately because a circuit and a cycle implies that you end up at the same point that you start. So let's have a look at a circuit. See, it says here, a circuit is a trail. Okay, so a trail can repeat vertices, but they don't repeat edges, right? So no repeated edges. That starts and finishes at the same vertex. Because remember, a cycle, you're going to end up, a circuit and a cycle, you should end up at the same point. So if you have a look here, starting off at B, I go to A, I go to C, I go to F, I go to G, D, back to C, and then back to B. None of the edges have repeated, okay? But the vertices have repeated. That's okay. This is called a circuit because I come back to the same point I started off at B and I came back to B again. Okay, so if you close that's called a circuit. And finally, a cycle is everything. You can't have edges, you can't have vertices repeated, and you do a loop. So here, it doesn't matter where I start. I could have started at E, go to B, go to C, go to F, and back to E. I never repeat those points except for the starting point. Okay, so that's the difference between a cycle and a circuit. Once you understand that and you're able to identify them, that's what the first exercise is. You need to identify walk, trail, path, circuit, cycle. That's when you can apply Eulerian trails, circuits, and Hamiltonian pathways. Okay, so that's